Alright, let's look at the homework 3, problem number 26. Alright, so we have this function given, f of x equals x minus 9 over absolute value of x minus 9. Then we want to evaluate the following limits. Alright, so let's do that. Alright, before we get into the limit, we have to understand this function. This function is a piecewise defined function because of the absolute value sign. Alright, so let's look at that. And you can see that the denominator becomes 0 when x equals 9, because 9 minus 9 is 0. So function is not defined because we cannot have a 0 denominator. So it's going to be defined either x is greater than 9 or less than 9. Right? So f of x is really two separate functions depending on the x value. Right? And first case is if x is greater than 9, right? And the second case is if x is less than 9, right? So when x is greater than 9, which means that the x minus 9 will be positive, which means that the absolute value sign doesn't do anything because the quantity is already positive, and absolute value sign of a positive number is the same positive number. All right, so this is going to be x minus 9 over, right? So you can just remove the absolute value sign. So we have x minus 9, right? But if you divide the same thing by itself, you can see that this is going to be just 1. All right. And when x is less than 9, right, so we have x minus 9 is going to be negative. What the absolute value sign does is to negate it so that it becomes positive. So what it does is absolute value sign is the same thing as putting a negative sign in front of x minus 9. Right? Then you have x minus 9 on top. Then you can cancel, just like before, we cancel these to get 1. And we can cancel these to get 1 over negative 1, which is a longer way of saying negative 1. All right? So this is a function. All right? Then let's look at part A. So part A, we want to find the limit of this function f of x as x approaches 9 from the right because of the plus sign. All right. So if x is approaching 9 from the right, so which means that you can think of x being slightly larger than 9. So we are looking at the top one because x is slightly larger than 9. Which belongs to the first function. So this is really a limit of the first function is 1 as x approaches 9. All right, but the limit of 1 is 1. All right, so let's type it in. All right, limit is 1 there. All right, check the answer. All right, we got that. All right. Next one is as x approaches 9 from the left. All right, so let's do that. So B, if you were to approach 9 from the left, all right, so you can think of this x being slightly smaller than 9, which means that you're going to have to use the bottom function. So you have a limit as x approaches 9 from the left of negative 1. Bottom formula, I should have said. All right, then it's going to be limit of negative 1 is still negative. Negative 1 is negative 1. All right, so let's type it in. All right, so this comes out to be negative 1. All right, so put negative 1 there and check the answer. All right, so we got that. All right, then we want to find the f of 9. All right, so this has nothing to do with, I have to do part C first. All right, so we want to take the limit. So this is a two-sided limit of f of x as x approaches 9. All right. So in this case, the limit does not exist. So I'm going to put the D and E. Since right-hand limit does not give you the same number as the left-hand limit. Right? In order for the both side limit to exist, the left side limit and the right hand side limit have to agree with each other. All right, so answer is does not exist. So here. All right, let's check the answer. All right, we got that. All right, and the last one is just evaluating a function at x equals 9. All right, as you can see that when x equals 9, denominator is 0, which means that the function is undefined. So D, f of 9 is undefined. All right, so let's find the answer. Whoops, sorry. All right, so f of 9, you can say does not exist. Check the answer. All right, we got that. All right, that's it. I hope that this was clear.